Imagine waking up one day and the sun is gone. What happens next? The sun, our constant companion in the sky, has been the center of our solar system for about 4.6 billion years. It provides the energy that fuels life on Earth, drives our weather systems, and even influences our moods. But what if it suddenly disappeared? The immediate effects would be catastrophic. Within minutes, temperatures would plummet, and within days, the surface of our planet would freeze. Life as we know it would cease to exist. But let's take a step back and explore the sun's life cycle to understand how it will eventually meet its end. Our sun is the life-giver of our solar system, but even stars have a lifespan. The sun was born from a giant cloud of gas and dust, known as a solar nebula. Over millions of years, gravity pulled this material together to form a protostar. As the protostar continued to collapse under its own gravity, temperatures and pressures in its core increased until nuclear fusion ignited, giving birth to our sun. In about 5 billion years, the sun will exhaust its hydrogen fuel. Currently, the sun is in the main sequence phase of its life, where it has been for the past 4.6 billion years. During this phase, it fuses hydrogen into helium in its core, producing the energy that we receive as sunlight. However, this phase won't last forever. As the hydrogen in the core is depleted, the sun will enter the next stage of its life cycle. The core will shrink while the outer layers expand, transforming it into a red giant. The sun's outer layers will swell, possibly engulfing the inner planets, including Mercury, Venus, and potentially Earth. The sun will become 100 times larger than its current size, and its surface will cool, giving it a reddish appearance. The intense heat and radiation from the expanding sun will strip away the atmospheres of these planets, rendering them uninhabitable. Earth, if not engulfed, will become a scorched, barren rock. The oceans will boil away, and any remaining life will be extinguished. After the red giant phase, the sun will shed its outer layers, creating a stunning planetary nebula. This nebula will be a beautiful, glowing shell of ionized gas expanding into space. The core that remains will be incredibly hot and dense, known as a white dwarf. The ejected material will enrich the surrounding interstellar medium with heavy elements, which can contribute to the formation of new stars and planets. What's left? A white dwarf, an Earth-sized core that will slowly cool and fade over billions of years. This white dwarf will no longer undergo fusion reactions and will gradually lose its heat, becoming a cold, dark remnant known as a black dwarf. The solar system will become a cold, dark place. Without the sun's warmth and light, the remaining planets will drift in the darkness of space. The once vibrant and dynamic solar system will become a frozen, lifeless expanse. To survive, we'll need to find a new star to call home. This means venturing beyond our solar system to other stars and planets. The search for exoplanets, planets orbiting other stars, has already begun, and scientists are optimistic about finding potentially habitable worlds. Colonizing other planets and building self-sustaining habitats will be essential for our long-term survival. The knowledge and experience gained from this endeavor will also help us protect and preserve our home planet for as long as possible. And perhaps, from the sun's ashes, new stars and planets will be born. The cycle of stellar life will continue, as the material from our sun contributes to the birth of new celestial bodies. The story of our sun is a reminder of the incredible processes that govern the universe. From its birth in a cloud of gas and dust to its eventual demise as a white dwarf, the sun's life cycle is a testament to the beauty and complexity of the cosmos.